everyone, today we are going to learn the new content, precipitation titration method. Precipitation titration method is another type of titration analysis which is based on the precipitation reaction. In high school, we have been exposed to a lot of precipitation reactions, such as 1. The reaction between silver nitrate and sodium chloride with white silver chloride precipitate. Second, the reaction between lead nitrate and potassium iodide with yellow lead iodide precipitate. Third, the reaction between silver nitrate and sodium thiosulfate will produce silver thiosulfate precipitate. But the precipitation of silver thiosulfate is unstable and will further hydrolyze to form black silver sulfide. Therefore, the yellow or brown mixed precipitate of silver thiosulfate and silver sulfide is finally obtained. To ensure the accuracy of the quantity analysis, the reaction for precipitation titration must meet the following requirements. First, precipitate should have a fixed composition with small solubility. Second, reaction rate should be fast and not easy to form a supersaturated solution. Third, the stoichiometric relationship is clear and there is a suitable indicator for the indicating of endpoint. Fourth, the phenomenon of adsorption does not affect the endpoint observation. Although there are many reactions producing precipitates in nature, few of them can be used for titration analysis. It is more practical to generate precipitates of insoluble silver salts, that is, adjointometry. In adjointometry method, silver nitrate solution is used as a titrant. Bromide, chloride, iodide, thiocyanate, and silver can be measured by the reaction of halogen ions with silver ion to form silver X precipitates. The adjointometry method can be divided into 3 types, according to the used indicator, following the founder's name, Moore, Volhard, and Fayence. The Moore's method is a method for the direct determination of chloride or cyanide in a neutral or slightly alkaline solution with potassium dichromate as indicator and silver nitrate stand solutions as titrant. Taking the detection of chloride as an example, with the continuous addition of silver nitrate, silver chloride first precipitates due to the lower solubility of silver chloride than that of silver dichromate. After the fully quantitative precipitation of chloride in the solution, a slight excess of silver ion will react with dichromate to produce a brick red silver dichromate precipitate and indicate the end of the titration. The 2 main factors affecting the accuracy of the titration in the Moore's method are the amount of indicator and the acidity of the solution. The concentration of the indicator, potassium dichromate, is generally selected as 5 times 10 to the minus 3 power mole per liter, and the pH of the solution should be controlled within the range of 6.0 to 10.5. In addition, interference ions must be eliminated before titration, and vigorous shaking is required during titration. The adjointometry method, using ferric ammonium sulfate as the indicator, is called the Volhard method. The Volhard method can use thiocyanate as a standard solution to directly measure the silver salt concentration. Moreover, the concentration of chloride, bromide, and iodide can also be determined indirectly by using both of silver nitrate and thiocyanate as standard solutions. Let's start with the direct measurement of silver. Under acid condition, the concentration of silver can be directly titrated by potassium thiocyanate or ammonium thiocyanate stand solution with ferric ammonium sulfate as an indicator. White silver thiocyanate precipitate first occurs in the solution. After all the silver has been quantitatively precipitated, extra thiocyanate and ferric will form a red complex to indicate the endpoint of the titration. The direct titration is usually carried out in 0.1 to 1 molar per liter nitric acid solution. The necessary amount of indicator, such as ferric ion, is generally 0.015 molar per liter, so that a clear endpoint can be observed. In addition, solution should be sufficiently shaken in the process of titration to prevent the adsorption of precipitation, which will lead to the titrating endpoint being advanced. As for the indirect method of Warhead, it is often used to determine the halide or thiocyanate. The indicator and the titrant are the same as the direct method. The difference is that the excessive standard solution of silver nitrate is first added to make the halogen or thiocyanate ion completely form the corresponding silver salt precipitation, and then the surplus of silver nitrate is detected by back titration using the thiocyanate standard solution. Herein, it should be noted that the indicator should be added after the complete precipitation of silver salt, never added in advance. Similarly, the indirect method also needs to consider the acidity and the amount of indicator. Here, I would like to ask you, can we use the Warhead indirect method to determine the concentration of chloride or iodide? How about the accuracy of the results when measuring chloride or iodide? The last adjointometry method is the Fayence method. It applies the adsorption indicator to determine the halide concentration. Adsorption indicator is actually a kind of organic dye. When absorbed on the colloidal precipitation surface, the structure of the indicator may be changed due to the formation of certain compound, thereby causing the change of precipitation color and indicating the endpoint. For example, when using silver nitrate as standard solution for the determination of chloride, fluorescein can be used as indicator. It is an organic weak acid, dissociating in solution and yielding yellow-green film. Before the stoichiometric point, silver chloride is precipitated and adsorbed extra chloride in the solution to form complex. The negatively charged film cannot be adsorbed and makes the solution exhibit its yellow-green color. After stoichiometric point, the silver chloride precipitate adsorbs the excessive silver to form this complex, which will strongly adsorb the negatively charged film, making the color of the precipitate change to pink. In the Fayence method, the color change of the indicator occurs on the surface of the precipitate. Therefore, to ensure the endpoint clear, it is necessary to keep the precipitates in the sol state to increase the specific surface area of the precipitates. The coloration ions of the indicator should have opposite charges from the ions added to the standard solution. At the same time, titration requires the control of acidity. It is generally required that the pH of the reaction system is greater than the pKa value of the indicator. The most important thing is that the adsorption capacity of precipitate on the indicator should be slightly less than the adsorption ability toward the ion to be measured, and certainly not too small. We can choose a suitable indicator for the system according to the adsorption ability order provided here. Relatively, the experimental conditions of the Fayence method are more stringent. In this part, we focus on three different types of the adjointometry method: the Moore method, the Warhead method, and the Fayard's method. Then, in the end of the class, I would like to ask you to think about two issues. First, why is it necessary to strictly control the acidity for these three precipitation titrations? Two, what are the commonalities and differences between the three methods? Thank you for your attention. See you.